Everybody. Hope you guys are doing well. Let me check if the stream is active. Hmm? Yeah, so our stream is up and running, and today we will be continuing with our OOP journey. And like this is uh, like this is one of the last topics that we were yet to cover. So we will try to cover this as well. So today we are going to talk about iterators, right? Now, iterators is based on something called as an iterator pattern, right? Now, what does the iterator pattern says is, so what we are going to do is we are going to do decoupling of the iteration logic from the underlying data structure, the iteration algorithm, and the iterable object. And the client that wants to iterate can change independently. Iterators allow consumers to pull values from a source one at a time. So basically, what we are going to do in iterator pattern is we are going to hide the underlying iterating logic from the user, and the user only will get the uh, will get the data one at a time, or it will allow consumers to pull values from a source one at a time. So the main goal of iterator pattern is basically to decouple. Okay, let's write. So iterator pattern decouples the iterating logic uh, or hides the uh, the so basically the iterator pattern decovers the iterating logic or hides the underlying implementation, so that the user uh, like should not worry, uh, or the user need not worry of how the iterating logic is getting implemented. Okay. Now iterators are a very foundational idea in modern programming. Now they offers a sequential way to access elements of an iterable object without the needing to expose the object's underlying data structure. And it is also called as an aggregator because it will aggregate, or anything that can produce a sequence of values can be thought of an aggregator. Now, in simple terms, iterator will allow us to traverse through a collection and iterable without needing to know the intricacies of how the uh, underlying data structure is or how it is stored. This allows the iterable algorithm and the iteration algorithm both to change independently of the client we want to iterate. So basically what we are going to do is, so irrespective of the data structure, like whether it is stored in an array or whether we are going to store it in a linked list, we are not worrying about how it is stored. Basically, what my iterator will do is, it will basically loop over, or it will iterate through objects and give me the results. Now, without iterators, yeah, so the thing is, suppose if we did not have this iterator object, right? So then if you are going to implement an thing that will iterate, then what will happen is, now each iterator implemented will be tightly coupled to the data structure, right? That we are if suppose if we did not have the iterating pattern, then the way that we loop over through a linked list will not be the same that we loop over through an array, right? So basically what we would be doing is, we would be implementing every data structure, and we would be implementing an independent way to iterate all those uh, data structures by in other words, what we would be enable is tight coupling, right? So because the iterator developed to iterate over a linked list will not be able to use to iterate over arrays, right? So uh, so basically what is going to happen is, now these suppose if we did not have the iterator pattern, then we would have developed iterators for each data structure, right? So by when we do this, what basically we are enabling is tight coupling, right? So each iterator developed for each data structure will not be able to use for another one, right? For example, if you developed a way to iterate over through a linked list, the same method cannot be used to iterate over an array. So basically what we have achieved there is tight coupling, right? So by using iterator pattern, we are not worrying about the implementation, or we are kind of achieving some sort of loose coupling. Every time we want to change the iterable or the way we iterate, that change will cascade, and we might also have to make changes, right? So basically that's what is saying, right? Every time we want to change the data structure without the iterator pattern, we will have to change the way we are iterating as well. Now so basically the main goal of iteratory pattern is basically to iterate over a collection uh, without exposing how the underlying data structure is implemented. Modern languages usually have integrated the iterator pattern either through custom syntax or in the standard library. Now in this chapter in this we'll see both the iterator as well as the yield statement, or lazy evaluation, and enums. What are they and why do we use them? Now let's see the iterator pattern. So the iterator pattern will decouple the client code from the iterable object's internal structure. The only condition is that the that object should be iterable, or it should be a collection, right? Basically, an iterable object is an object on which you can loop over. So these are little bit of confusing terms. Let's see, what do you mean by iterable object? Okay, so now the second term we have is basically called as an um iterable object. Now iterable object is basically an object that can be iterated over using a for loop. In other words, it is capable of returning its members one at a time, permitting it to be looped over. So basically, okay, this is what my iterable object would look like. And an iterable object, okay, and one at a time. So this is basically what an iterable object is. So the next question is how to check if an object is iterable. Like how should we come to know whether it's an iterable or not? Okay, so basically, in Java, an object is said to be iterable. In languages like Python, you have a dunder method or a magical method called as underscore underscore iter. Now in Java you have it's an it Java we say it is an iterable if we are able to if it implements uh, the iterable interface, right? Okay, and yeah, so in Java we say it is iterable if that data structure is kind of implementing the iterable interface. Now, so so let's see how we like what are the elements or what do we have in an iterator pattern, right? So basically, the iterator pattern will comprise of two components. So we have okay, let's see, it comprises of compo it comprises of two components. Basically, one is something called as the iterable. Uh, this is iterable, and then you have something called as iterator, right? Now, these are basically two interfaces. So now there will be two classes which are going to implement, right? This is my iterable. Now it has a method called as get iterator. So this is the method that is present here. These are all our interfaces, right? So okay, let's reduce the size. And then here we have something called as iterator, and then you have two methods here. One is next, and then you have has next. Now this concrete there will be a method or there will be a class that is going to do the concrete implementation, right? So that is going to be okay. So this is how the concrete implementation will work, right? So basically, there will be a class called as iterable, which is going to do the concrete implementation, and there is one more. Uh, there is one more class which is going to do the concrete implementation. So there is something called as concrete iterator that will implement this uh, iterator class, and it would have two functions, right? Next, two methods will be present here. One is uh, next, and the other is has next. Okay. Now, so basically, so basically, this is going to be an interface. This is implemented by Iterable, and then we have something called as an iterator interface. Now this will define the basic. So basically, Iterable is going to this is going to create my iterator object, or this is going to return my individual elements. Now this is going to be implemented by the iterable class. Now the iterator interface basically will have methods for performing operation, that is moving to the next item and checking if the next item is present or not. Now this is an interface which is implemented by the concrete iterator class. And okay, these two classes are okay. Okay. So this the concrete iterable and the concrete iterate, these two classes will be linked to each other. So let's get rid of this. Now, let's consider a example, right? For example, let's assume that we have an inventory. Now, okay, so like now there is a main character here, and there is an something called as an inventory. So let this be my inventory, and this is my character. Now we want to design. Okay, now the character can carry 3 elements at a time. However, we are not sure if you would like to change that requirement in future. Items are like things, weapons, tools, and potions. Now we want to design an inventory such that it's easy to switch or cycle between these items, making one at a time. So basically, yeah. So what it is going to do is okay, and the inventory has three. Or basically, we have 3 items here. This first. Okay. Now, what this is going to happen is uh, okay. Now, okay. So this inventory class should be able to switch between these items, right? So between item one, item two, and item three. So we are going to design it such a way that we will be able to we will be able to access the elements of the uh, uh, or what all elements that the character can carry, right? Now iterator pattern so he's saying that so iterator pattern is going to be a perfect match, right? Because here we don't know how the items are stored, right? Only thing is we want each of them to be active, right? So this is a very good example, right? It might you might be carrying them in the bag, or you might be placing them in the box. We are not worrying about that, right? So our only goal is that using this inventory we should be able to get each individual items. So here is when we can make use of an iterator pattern, right? Now okay, so now what if we try to implement without using the iterator pattern? Okay, so uh, okay. Now, how would we implement this basically? Okay, let this be my so without iterator pattern, how would it look? So this is suppose class inventory, and then now I would be using three getters and setters, right? So one for each item. So I have item one, then I have item two, and then I have item three. So now in my next item method, what I would be doing is I will try to increment the index by one, right? So that I can get the three items. But by doing this, what is the drawback if I don't use the iterator pattern is um, so the fun thing is we have hard coded it for three possible items, right? Like what if we add another item? So then there is where one issue arises. The other is what if we want to categorize the items into different subtypes. So, for example, this can be weapon category, this can be tools category, and this can be like map category. So, how will we be able to cycle through individual items or individual categories? How can we solve the problem while rating the possibility? Our goal is that we should be able to iterate over all of them, right? So basically, now it will become more complex, right? To iterate through all of them. So iterator pair will provide a more general approach, right? Because it does not depend upon what you are or how the items are categorized, right? The only job is basically to give to return the the next element, right? Okay, and so basically, so this is basically how the iterator pattern will work, right? And that is the reason why iterator pattern is more easy, or it's more it kind of basically hides the underlying implementation and makes it like a general method that is available to all, right? All objects that can be which kind of on which you can perform iteration, or it can store some sort of or it can be a collection, right? Okay, now there is something called as generators, right? Okay. Okay, now so there are so the iterator interface generally has three methods, right? One is basically the has next, that will check if there are more elements to iterate, and then is basically next, right? So So yeah, so basically this is as next check if we have a next element, or we can iterate over the next element or not. And next is basically going to return us the next. So this is going to be my bool which is getting returned over here, and then this is basically where I'm going to return my next element. This is also called as aggregator, right? As we are able to aggregate or get the individual values. And then there will be one class which would basically um, uh, what do you say, a concrete, which would be the concrete iterator implementation, or basically which would be the one that will be responsible for performing the iteration or for traversing the collection or the data structure. Now then the next thing that we have is generators, right? So we studied about iterators, like it kind of decouples the iterating logic, and it kind of provides a way to decouple the iterating logic from the iterable object or the collection, right? Now let's see like what is a generator and why we need it. Okay, before we go to generators, let's see enumerable, right? Now, enumerables are basically native implementation of the iterator pattern. Now, in allowing you to iterate through collections in a decoupled fashion, they offer a way to access the elements in a collection sequentially without exposing the underlying details, just like the iterator pattern. Now, in .NET, we have the interface enumerable. Okay. Okay. Now, what is enumerables? Let's see that. Hmm. Okay, so now enumerable. Now enumerable basically refers to an object or a data structure that can be iterated over, meaning you can traverse through its elements on one by one. The exact definition will vary depending upon the language or environment. So basically, enumerables are something. Basically those these are those objects or data structure that can be iterated over. Let's see, enum versus uh, enumerable. So like there is something called as enums, right? That we study. So enumeration is something else. Okay, so even this. Okay, okay. So okay, let's study what enums are. Enum or enumeration, right? So basically, the goal of having enum or enumeration is basically to store to create uh, or to create a collection of related values, right? To create a collection of uh, related values, like uh, so one example could be like days of the week, right? For example, these you could have Monday, Tuesday, Wednesday. So these are all related to one collection, right? For example, you could have your Monday, Tuesday, uh, Wednesday. Okay. And then so these are all related to each other, right? So all of these comes in like days of the week, right? The other example of enum could be something called as um, like the temperature, right? For example, it could be for example fruits. Again, those are all related, right? So um, the goal of enum is basically to create, or enumeration is basically to create a collection of closely related objects. So that is what we say an enum, right? uh, Basically these all can be used as a type, right? For example, like you can have type Monday, type Tuesday, Wednesday. So instead of making you use of these individual, you can group them and refer to one single type, right? Basically, yeah, it will make our collection or set look more uh, organized, right? Um, Basically, we are kind of grouping them uh, into we are kind of grouping the collections into a named constant, right? Now, and in enumerable is uh, something enumerable is basically referring to an object which can on which you can or a data structure that can be iterated over, right? For example, if you can iterate over uh, an array, then you say that it is enumerable, right? Okay, so enum is for handling these related values, and enumerable means something or a collection which can be iterated over. Now, then is my yield statement, right? The yield statement offers a simple way to implement custom enumerators, right? With the support of iterators, enumerators usually have some equivalent for the keyword, right? So basically, yield return is used to return the next value in the iteration, and so yield kind of works with two things, right? So you have one is so now then you have something called as yield, right? So let's say this is my yield. So it has two variations to it. The first is basically when we use it with the yield return, we say uh, return the next value on iteration, and then yield break is previous value. This is going to indicate end of iteration. This is nothing but called as generators, right? So and then one more you have something called as lazy evaluation, right? So inverter iterators are lazy, right? So uh, yeah. So now the issue with yield is until you we don't have the first value, none of the code that is written will be executed, right? The only thing that happens is that we get back an enumerable or depending upon what we have set the return type of the yielding function to. Okay, now you might say that enum or enumerable, in both you have something common, right? So let's enum, and then now if you see here, both of these words have something in common, right? That is the use of enum, right? So this also has enum, and this is also has enum in it. So these are related to each other in a way where we say that um, basically we are using a countable set of values, and the process of counting those values is called as enumeration, and the process of declaring is something called as enum, right? Okay, so they both of them are derived from a word called as enumerate. Enumerate basically means something which can be counted. Okay. Okay. Now let's see why we have generators, right? So as the name suggests, the goal of generators is basically to um, uh, provide an efficient way to work with large data sets by allowing us to generate one value at a time, right? Lazily, without the need for or without the need to store the entire memory, right? Okay, so basically, we are going to uh, generate one value at a time uh, without the need to store or to the entire sequence in the memory at once, right? So basically, we are something doing some sort of memory efficiency, right? Generators allow lazy evaluation, means values are generated only when we are asked. That is when the next method is called. For example, so instead of looping through all, or instead of storing all the data, you can only uh, okay. So yeah, instead of storing the entire data in the memory and then looping it through over, what you can do is you can do a lazy evaluation using generator to generate one value or a value or that we need without the ability or the need to store the entire data structure and through loop over it, right? Now this is useful when we have an infinite number of infinite sequence stored, right? For example, sequence of all primary numbers, right? So uh, because if okay, so let's see an as an example, right? For example, what if you want to create a list of an infinite sequence? For example, all possible prime numbers. That is impossible, right? Because if we create such a big list, that will be infinitely large, right? And we have a limited memory, right? So the solution is we use generators By generating, what we are doing is we are not storing the entire array. Instead, we are generating the value as and when we require them. For example, okay, let's see. Uh, okay. Now, to the way to create is generator or to perform lazy evaluation is using the yield statement. So now, how should we do this generation, right? Uh, Generators are uh, created using the yield statement. Okay, now when the so how so like now let's see working, right. Okay, so the yield statement is executed, the function is passed, and the value specified by yield is returned to the caller. The function's local state is saved so that it can continue from where it stops from. For example, uh, let's see. Okay, this is so what it is going to do is it is going to pause and return the value to the caller. The function's local state is also saved so that it will continue from where it left off when the next value is requested. Okay, so this is a loop, right? So when I come to let's see this code. So initially, so my okay, this max I have set to 5, right? So this is 5. Initially count is 1, right? So 1 is less than 5, so I'm going to come here. So this is going to pause and return the current value. So what I'm saying, what is count? So here, so now my counter is going to get 1, and then mm, so now here the execution is paused. But the next time when I come here, uh, okay, so it has paused over here, right? The current value of count continues from here the next time. If this would have been a normal function, then once you return the function is over, right? But then okay, once this is gone, so the next time I come, uh, mm, okay, Huh? Okay. So basically, we are kind of keeping a track of the state as well, right? Oh, I see what is happening here. So the next time when we call this, or this loop is going to be execute stuck here, right? So the next time when we check is was less than or the yeah, then we are going to come over here and then we are going to implement it to 2. And then when we come over here, is 2 is less than or equal to 5. And then when we encounter this yield, then we are going to print 2. It's something like that. It's happening. The advantage is basically if you have an infinite sequence, right? For example, whenever you are told to generate an infinite sequence of numbers, so I mean you cannot store all the sequences in the memory, right? Because you would need an infinitely large array depending upon how many number of elements you have here. So and in such places, suppose what if we need individuals at part two at a time, right? So instead of storing the or creating an infinitely large array, you kind of uh, get the values on fly, right? So if I need the first value, then I yield it. So basically, that is the so yield is going to make our or convert our function into a generator function, right? Uh, So basically, now this feature is um, this feature is specifically available in Python because in Python, or the the main focus to use Python is basically for processing data sets, right? Either using NumPy and other libraries, right? So in the moment when you come to time series, right, you will have an infinite number of sequence, right? So basically to handle all those datas, you need something that could potentially work with infinitely large data sets. So that is why Python has this specific use case for using yield to make a function to a generator, so that like if we need to operate, you can generate one value at a time, and we need to store the local state, right? So for the next value that we are going to use, we could use the previously stored state. So since Python is used for data processing at a large, basically for large data sets or sequences, right, we don't want them to be stored in the memory. So initially what we will do is we will take np array and then store it into or in like extract it from a csv file or something like, and store it in our array, right? But what if that cs is massively large, right? What if it has 2 billion, 3 billion records? Now there is what the problem occurs. To always convert it into an np array is going to be a problem, right? So there is what we use something called as the yield statement. Let us see an example where we are going to use the yield statement to get data, right? For example, if you are reading a file, right, and instead of reading the entire file at once, what you do is you kind of read one file line at a time. So that kind of makes it a bit more memory efficient, right? For example, infinite growing data sets. So suppose if you have a data set that is going to increase in large, right? So when we operate on that data set, we need to store the state as well, right, of what we had previously operated on. At such time, our consideration real comes as to real is more important. Our real comes into the picture, right? Okay, so like let's conclude, right? So basically, so first is something called as iterable objects, right? So any object, an iterable object is an object that implements the iter method, right? Or okay, iterable object is the one that implements the iter method using which we are able to uh, iterate it uh, to give individual values, right? or using which we are able to iterate or like use a for loop or a uh, for loop to perform and uh, return return single values. Now then is something called as iterator uh, pattern, right? So what does it state is you uh, hide the underlying uh, data structure, and irrespective of the data structure, irrespective of the data structure that we are using, we are still able to uh, iterate over uh, the structure. That is what iterator pattern says, right? These are two different things. An iterable object is something which can be on which you can loop through, or you can or basically that implements the iter method. And then iterator pattern is basically of hiding the underlying data structure irrespective of the data structure that we are using. For example, if even if you're using linked list or array, so we are not we are hiding how it is implemented or stored. The only thing available to us is the iter method that is basically going to iterate over the structure. Let's see the difference between an iterator pattern and an iterable object. Also, iterable is object is something which can be looped over. An iterator pattern is basically a design pattern that provides sequential access to elements of a collection. So without the iterator pattern, we would have to like implement the for for every data structure, right? An iterable object is anything on which you can iterate on. So for example, for iterator pattern to be used, the object should be an iterable object, right? We should be able to loop over it. And an object is said to be an iterable object only when it kind of implements the iter method, right? Uh, so basically, all okay, so what we'll say is we are kind of generalized how the iteration will be written. Like you will have two methods. One is next, and one is as next for checking if there is another element in the list. And then uh, so actually we will be just using a simple for loop. Okay, so in reality we would be just I see what has happened here. Let's make this medium. Okay, so this is basically going to define our data structure, right? So yeah, this is we have defined our data structure linked list, and then oh no, this is also linked list iterator. Yeah, this is defining our data structure. Okay, and we have this is going to append at the end, right? This for adding a new value and for create. So till here, basically, we are going to create the data structure, I guess. So till here is when our data structure is getting created, right? We do have this thing, and then what I'm going to do is this is for adding members in the list. Now this for loop is going to call this iter method. Now this is how it's internally linked in Python, right? So the way that for loop works is that is some that is how the protocol is defined, right? So what it is going to do is the for loop will call the underscore iter on the list, and then which in turn will call this. So this is going to call this iterator class, right? So here is my class getting being called. This is where it's getting called, and this is going to produce the iteration. So I am just looping through it like a normal array. Like we are not mentioning how the looping is happening. The looping is happening here, which we are this implementation like we don't have access to, right? So yeah, so that is the reason you could iterate over the for or like you couldn't. Okay. Yeah, so even if it's a dictionary or any other item, it will just use the for loop. Okay. Yeah, so even though that's the reason, even though if you're using list and dictionary, right, you will iterate over them both just by using a single for loop. Like even though there are two distinct what do you say data structures, what has happened is internally the iterator pattern has been used. So even though they are different data structures, still you can just iterate over them using a normal for loop, like how we have done this. So basically we would be just using this part of the code to iterate over. This is all present internally. I guess. So basically, an iterator pattern would be applied on an iterable object, right? These are both linked. If an object is not iterable, then you cannot use the iterable pattern. And then is something called as generators, right? So what if we have an infinitely large sequence? The use case of using generators is when you have an infinitely large sequence and you need to operate on individual values, right? So whenever that case comes in, make sure to convert our function into a generator function by using yield, right? So what we are doing is, instead of storing it the array, what we do is we make each single value be available on a fly, and whenever it is used in a function, the state of the when we reach this statement, we will stop the execution. We will return whatever the value is present here, and the state of the function also gets stored. Unlike in normal return, the function state is removed, right? But in here the function state will be stored. So for the next value we can use the previously stored function state. uh, yeah, so I guess yeah, that is all for this lecture. I'll see you guys. Yeah, so that is all about iterator pattern and generators, when we should use them. So basically iterator pattern, it's an design OOP design pattern that is implemented in some languages. So I just wanted to so even though it's a dict or a list, still you can loop over them using for loop, is because internally all of them are designed using an iterator pattern, right? So you just need to write the for loop and you do not worry how the iteration is going to happen. Okay, that's all for this lecture. I'll see you guys in another one. Till that time, take care. Bye bye.